Hello everyone, my name is Tilon Marasinghe and my index number is 216077B and I'm the team leader of group number 7 and today we are going to present about Turing machines. So first of all, let me walk you through the outline of the presentation. We will start with a thorough introduction to the concept and then discuss the history of Turing machines. Then we will move on to examples and demonstrations. We'll discuss about the influence of Turing machines on modern-day computer science. Moreover, we will present advantages and limitations regarding Turing machine concept, arriving at a conclusion and ending our presentation with recommendations. So this concludes the outline of the presentation, and let me hand out the presentation to Sandun to proceed with the introduction.
Thank you, Diloni. I am Chandika Sandun. My index number is 216005F, and I have contributed for this presentation by doing introduction part. Let's see the introduction. A Turing machine is a mathematical model of computation describing an abstract machine that manipulates symbols on a strip of tab according to table of rules. And despite the models of simplicity, it is capable of implementing any computer algorithm. And the other thing is, in the context of his work on the mathematical tools, Turing introduced Turing machines. And the other one is he developed these abstract techniques. Furthermore, he developed this technique to demonstrate that the following problems cannot be solved, calculated, or computed using this general efficient approach for procedure. So introduction's problem is the problem decide for every statement in first order logic whether or not it is derivable in that logic. So that called restricted functional calculus. See the entry on classical logic for an introduction. The other one is, this is also called as computing machine by Turing. And he defines it in Turing's original as a machine capable of a finite set of configurations. The last one is, this is an automatic machine, which means that any particular time the current state and symbol beans can totally define the device's behavior. I'm going to hand over to the Asiri.
Thank you, Sandhu. My name is Asiri Hashan and my index number is 216156R. Now I'm going to present about the historical background of Turing machines concept. The Turing machine was introduced by Alan Turing in 1936. His paper regarding the topic was published in the Proceedings of the London Mathematical Society in early 1937. Turing named them as automatic machines in 1936. They were specifically devised for the computing of real numbers. The name Turing machine was first given by Alonzo Church in review of Turing's paper in 1937. To discuss examples and demonstrations regarding Turing machines, now I hand over the presentations to Ravindra.
Thank you, Asiri. Hi, I'm Ravindra. My index number is 216096G. So I will be taking you all through the examples of Turing machines and a small demonstration how exactly this works. So a Turing machine is formulated using an indefinitely long tape, which is basically divided into cells containing certain figures such as zeros, ones, and sometimes empty spaces as well. And there is a header on top of each cell, which is basically moving from left to right, monitoring the cells, basically, I would say, moving the directions depending on the instructions given to the system by the user. So the head also can erase pre-written symbols as well as rewrite on symbols on the cells. So for the Turing machine to function, we have to interpret the symbols recorded on the tapes. So let's say if we are performing a certain mathematical function, we need to describe how ones and zeros are interpreted on the tape in terms of numbers. Sometimes there are certain instances where we need to come up with assumptions with regard to the configurations of the tape to carry out the interpretations. Now I will take you through a small demonstration on how certain functions are being carried out in this concept. So the Turing machines have arguments which represents operands that are being used for certain operations. And in this example, as you all can see, the machine would take 2 arguments per each number, 1 argument for number 3 and the other argument for number 4. And the header will start reading from the leftmost one. So basically, zeros are used to separate arguments, like meaning that the first 4 bits or the first 4 ones, I would say, represents the first argument, which is number 3. And the next block of ones represents the second argument, that is number 4. So if the machine calculates the sum correctly, the final tape would result in a single block of ones as represented in the diagram below. We can move on to the next slide. Yeah, so here we have different ways of formulating Turing machines, and all these variations would be equivalent to the original concept of the Turing machine at the end of the day. So the first one, the first variation, we can move the slide. Yeah, so the first variation we can see 2-way infinite tapes, which are the ones which has 2 infinite ends in both the sides, left and right, in which the original tape usually has only 1 infinite corner. And then we can move on to arbitrary read-write heads, which has multiple read-write heads, and therefore it doesn't alter the concept of Turing computability. And the third one would be multiple tapes, which where the machines use multiple indefinite tapes instead of 1 single tape. And 2D tapes is another category of tape where we can where I can stretch the tape up and down as well as left to right. And finally, the arbitrary finite alphabet is where we use multiple symbols rather than just using ones and zeros in order to increase the power of Turing machines. And with that, I'm done with my part of the presentation. Over to you, Oshan.
Thank you, Ravindra. My name is Oshan Gunaratne and my register number is 216040G. Okay, let's turn to the next point, which is about influence of Turing machine on computer science. The father of computer science, according to many, is Alan Turing. S. Barry Cooper handled most of the planning for his Centennial Festival in 2012. This led to a number of activities and projects that popularized Turing's theory among a wider audience. The influence of Turing machine should be handled with extreme caution according to research. And one should be careful not tempering computer science. Okay, let's turn to the subtitle, which is about impact on theoretical computer science. The Turing machine and its theory are currently regarded as some of the theoretical pillars of computer science. It is a common resource when researching fundamental issues like what is an algorithm, what is a computation, what is a physical computation, what is an efficient computation, etc. One of the most crucial models in theoretical computer science for figuring out how computers operate and interact with one another is the Turing machine model. It serves as a foundational paradigm for study into many different computer science subdisciplines. Turing's works was part of tradition of theoretical computer research dating back to the 1920s and 1930s. The Turing machines was regarded as the finest example of computability ever. His work was well known within the tradition of formal logic developed by the Post and Church and Davis and Klein. In order to reflect on the new computer devices, their capability and limits, and do so in a more methodical way, theoretical models were needed in 90s, 50s. One of the early studies on computational exploratory theory, which presented the multi-tape Turing machine as the fundamentals computer model, was published in 1965. Okay, let's turn to next point. Turing machine and the modern computer. In several accounts, Alan Turing has been identified as the father of computer science. The blueprint of the modern computer can be found in von Neumann's design. Turing was also involved with the construction of devices used for decrypting the Enigma code. Claims that Alan Turing was the inventor of the computer have been scrutinized by some historians. Claim about his give a distort and base picture of the development of the modern computer. At best, he is one of the many who contributed to one of several historical developments. The universal Turing machine is by many still considered as the main theoretical model of the modern computer. With these early minimal designs, much effort goes into developing more efficient coding strategies. The result was a series of experiment machines such as the MINAC TX000. Theories of programming. The idea and any general purpose machine can in principle be modeled as a universal Turing machine also became an important principle in the context of automatic programming. This is introduced in several forms in the 1950s by people like John W. Cahill and Sol Gone. The role of the Turing machines was computer science should be situated rather on the theoretical level. Its ability to mimic machines through its manipulation of program as data in one of the basic principles of modern computing. Moreover, its robustness and naturalness as a model of computability have made it the main module to challenge if one is attacking version of the Church Turing thesis. Okay, now I invited to Sahani to explain about the next point.
Thank you, Oshan. I'm Sahani Disanayaka and my index number is 216028D. Let's discuss the advantages and limitations of Turing machines. Advantages. The first advantage is the unlimited memory. Turing machines have an unlimited memory capacity, unlike the real machines that we use in our day-to-day lives. Yes, the storage capacity of real machines can be expanded by acquiring more storage media, but they are not unlimited. Can you go to the previous slide? Oshan? Yeah. So the second advantage is capable of simulating common computers. Turing machines have a capability to replicate all the computations performed by a real machine and execute them. Then the other advantage is simplifies the statement of algorithms. The real machines that we use specific algorithms, but Turing machines use more general algorithms. Therefore, it is more simple than the real machines. Also, Turing machines helps to classify decidable problems into classes. Let's say we have a decidable problem, then the Turing machine analyzes its complexity as well as how efficiently the problem can be solved. Then, based on those factors, the problems are classified. Moving on to the limitations, Turing machines do not model concurrency well. Concurrency is the ability to execute multiple processes at the same time. The Turing machines does not support this well. The other limitation is computational complexity theory. A good example for that is the binary search. Also, Turing machines are not designed for interactive use. Well, Turing machines were developed before the interactive use of computers became popular. Therefore, they were mainly designed for batch processing as well as the execution of the non-interactive tasks. Moving on to the next slide. The conclusion of our presentation. Turing machines are a theoretical model which can carry out any mathematical computation from simple to complex. We could even say that the computer was invented twice, once by Charles Babbage and once by Alan Turing. The Charles Babbage's one is the practical computer that we use, but the Alan Turing's one is the machine of the mind. As my fellow group members mentioned before, Turing machines have contributed for the development and growth of computer science researchers as well as mathematical investigations. Well, if there's a system that can compute something, Turing machine can compute it as well. So far, no system has been found that goes beyond a Turing machine. I'm handing over the presentation now to Madhusha.
Thank you, Sahani. Hi, everyone. I'm Madhush Deshan, and my index number is 216023H. And my contribution to this presentation is recommendations about Turing machines. A theoretical model known as a Turing machine is capable of doing any mathematical operation, no matter how simple or difficult. The most comprehensive, detailed, and accessible models of computing now available are Turing machines. And the theories that go along with them allow for constructive discussion of many ideas, including complexity. Turing machines have made significant contribution to the advancement of computer science as well as research. Let's see some advantages of Turing machines. Unlimited memory, capable of simulating general computers, help classify problems, and simplify the statement of algorithms are some major advantages of Turing machines. Then you can see these advantages, how people to solve computing problems. So we can easily solve problems in computer science and test the limits of computation by using this system. Turing machines help to do it smartly. If we develop and spread this system among students by including this theory in schools and universities, they can specialize in this theory and solve matters in a good manner. There are some limitations also in Turing machines. Do not model concurrency well, not designed for interactive Turing machines, have the drawback of being unable to accurately simulate the benefits of a certain configuration are some limitations. We need to research and find some solution for this limitation to get a better experience from Turing machine. These are the recommendations about Turing machines. Let's move to next slide to see our summary of the presentation. We talked about introduction, historical background, examples and demonstrations, influence on computer science, advantages and limitations, conclusion, and finally recommendation. I think you all got a clear idea about Turing machines. Thank you for joining with us.